Okay. So this one just summarize it, that if they give you a standard deviation of the population, you have to use the Z. If they didn't give you the standard deviation of the population and your sample is less than 30, you have to use T. So this is the formula for Z and T. We have mean, we have standard deviation here for population and sample, and here for everything is for sample for the T. What about the population proportion? You see, whatever we are calculating, of course, we calculate for the population proportion also. If you see the population proportion is, look at the example, they said 80% of the population, 30% of the student in the, for example, the college. So they give you a proportion of the population, and you already know that how you should calculate it based on the formula. There is for population proportion, don't forget that always there is 4 conditions. The binomial, remember there was 4 conditions for the binomial distribution. That 4 conditions always should be there for population proportion. And additional to, when we calculate the mean and variance, and mean and variance should be greater than 5. Don't forget that one also. So of course, for confidence interval for population proportion, we have to calculate sample proportion, that is P, and after that we have a formula to how to calculate confidence interval for population proportion. Look at the example. The union representing the bottle blower of America is considering the proposal to merge with Team Master Union. According to the BBA union by law, at least 34, it means 75% of the union membership must approve. A random sample of 2,000 current BBA members revealed that 1,006 plan to vote for the proposal. What is the estimate of the population proportion? So you see, they already give you the information that you need. They give you how many they are going to vote from 2,000, 1,006 going to vote. And after they mention that 75% have to confirm, of course. So here again, with the 95% confidence interval, they want you to calculate, do they going to, of course, get the vote or not, and why. So the first step that we have to do, we have to calculate population proportion. So based on the sample that we have 1,6 divided by 2,000, we get 80 population proportion. We have the formula. For population proportion, don't forget that always we are using the Z, not the T, right? Always for population proportion is going to be Z. So get the confidence level from the Z table, and we already have the sample proportion that is 80%. Put everything in the formula, we will get the margin that we want. So we can conclude that the merger proposal will likely pass because 80%, of course, the value is more than 70%, right? They need 70%, so they have more than 75%. So, of course, they have more than that. I will continue with the next slide. Okay, now we are talking about how we can get enough sample size, how we should know that how many sample is enough. Of course, we have a formula based on that. So what it will affect is how confident we want to be. For example, we want to make sure 99% or 95% or 90%. How much error we can tolerate, of course, is important. And how homogeneous or various is our population is very important. Based on that, of course, we can get how much sample size is enough. So we have a formula for sample size. N is sample size. And you see exactly the margin of error, our confidence interval, and standard deviation is here that to calculate. So what we can do here is look at the example. They said student in the public administration want to determine the mean amount member of the city council in large city earn per month. She would like to estimate the mean with the 95% confidence interval, and margin of error is less than 100. And the student found the report by Department of Labor that the standard deviation is to be 1,000. So how much sample? the sample size is going to be how much. So whatever information that we need from the formula we have here, right? So put everything in the formula. Here is a bit mess. Just use the formula up there. Put everything in the formula, your confidence interval, the tolerate for the error, and your standard deviation. You will reach to the number that is 385. Second example, the consumer group would like to estimate the mean monthly electricity charge for a single family house in July with $5, and now the level of confidence is 99% level of confidence, and based on similar study the standard deviation is $20. So now they want the required sample size, exactly the same thing that you did in the previous example. With the margin of error, your confidence interval, put everything in the formula, and you will reach to the value that you want. Okay, what about the population proportion, right? Whatever we are doing, we do for the population proportion also. How to calculate for the population proportion? So we have again the formula for population proportion. Here you see we have N as always. We have Z, that is our confidence interval. We have E, that is how much error we can get. And we have pi, that is a population proportion, right? So look at the example here. The American Kennel Club want to estimate the proportion of the children that have dog as a pet. If the club want to estimate to be within 3% of the population proportion, so you see that margin is 3, right? How many children would they need to contact? So this is a sample size. And confidence interval is 95. And of course, that the club estimate that 30% of the children have a dog. So the population proportion is 30%, right? It means that 30% they have and 70% they don't have. So if we know that the population proportion is 30%, 1 minus 30 is going to be 70, and we have our confidence level, that is 1.96 divided by 0.3, square it. So you will reach to 897 for the population proportion. The second example is exactly like the first example. The only differences is that is the time that they didn't give you the population proportion. If they didn't give you population proportion, it means that you just get 50-50, 0.5, 0.5. So the same example repeated. We do the same thing, calculate for the confidence interval, for the getting the value confidence level from the Z, and after that everything else is the same. The only thing is that they didn't give you population proportion. So what you do, you just get 50-50.